All right, we are going to work on our next math lesson, and I'm folding my paper into 8 squares because that's what we do. And I'm going to go ahead and draw the lines in of my 8 squares. Also on the other side. So last time we met, we talked about taking improper fractions and making them into mixed numbers, which is a really important, I would say it's a life skill. So today's lesson, we're going to rename whole numbers. So we're going to write our name in the corner. And this is lesson 6.6. And we're going to do pages 271 to 272. All right. So I'm going to go ahead and open my math book to 271. It almost went right there. So I'm looking at my math book, and it says that we're going to learn about renaming whole numbers when we're adding and subtracting fractions. Okay? So we have a problem here. It says Warren and Drake each had an apple. Warren ate 7/8 of his apple, which looks like this. 7 out of 8 shaded bars. Drake ate 3/4 of his apple, right? So this is 3/4. It's also showing us 6/8. Here's the 4. If you went 1, 2, 3, 4, right? You can see the dashed lines between the two. Makes it into 8, right? Because if we're adding two things together, they have to have the same denominator. We know that. So 7/8, Warren, plus 3/4 equals 7/8 plus 6/8. We converted this to have the same denominator as Warren's. If we take 7/8 plus 6/8, we have more than one whole, right? This is more than one whole. We only have 3 little tiny bits that aren't shaded. So we know when we add this to this, it's going to be way longer. It's going to be more than one whole. So we end up with 7/8 plus 6/8 is 13/8. And now we have to figure out how to make 13/8 into a mixed number. So we're going to say that, well, if we took 8 out of 8, that would be one whole. And if we subtract 8 from 13, we get 5 left over. So this is the same as 1 and 5/8. 1 and 5/8 apples together. Look at how this guy's thinking 3/4 equals 6/8. What a tasty apple. All right. So we're going to do a few problems like that together. Let's look at this last example before we go out on our own. This time they're adding 3 numbers together. 3/4, 1/8, 5/8. This 3/4 has to change, doesn't it? That's not going to work very well. If I have 3/4, let's zoom in a little closer so you can see it a little teeny bit better. If I have 3/4 here, that's got to be converted to an 1/8, right? So 4 times 2 equals 8. 3 times 2 equals 6. So it's going to be 6/8. So 6/8 plus 1/8 plus 5/8 is going to be more than one whole, right? We have 6 plus 5 is 11 plus 1 is 12. So we're showing it over here. We have 8/8 shaded, and then we have 4/8 shaded, right? So 12/8 is the same thing as 8/8 plus 4/8, right? So if you squint your eyes, you can see that one whole and 1/2 are shaded, 1 1/2, right? So the sum of 3/4, 1/8, and 5/8 is 1 1/2. All right. Okay. Now let's do a few of them together, and we're going to do them in a couple of ways. I think it's easiest to follow the green boxes. So let's look at 7/9. I'm going to back out a little bit. So if I have 7/9 plus 2/3, that's going to be the same as green box plus green box. Going a little bit over. And that's the same as green box, green box. So I have to convert this number, this 2/3, to a ninth, right? So if I have 7/9 and I make this one into 9, 3 times 3, whatever I do to the bottom, I have to do to the top. So an equivalent fraction to 2/3 is 6/9, right? So I just converted that so that now we're happy as can be with ninths. Now when I add these together, 7 plus 6 is going to be 13/9, right? And that's an improper fraction. So that's the same thing as 9/9 plus how many other ninths? 4/9, right? So if I have 9/9, I have 1 whole and 4/9 left over, right? Another way to do that, another really easy way to do that would be to do it this way. We could go like this and do our algorithm that says 13 divided by 9, right? So we can do it this way. 9 goes one time, right? And we subtract and we get 4. So we end up with 1 and 4/9. So they're showing us two ways to do it. You can say, oh, this is the same thing as 9/9 plus 4/9, right? Or you can use the algorithm and divide it. And again, this number on the top, the quotient, the answer is your whole number. This number right here, the remainder, becomes your numerator, and the divisor over here becomes the denominator. Okay? All right, let's look at number 2. So we're going to use the green boxes. I'm just drawing out the green boxes just the same as they are on the paper, but then we added a little bit over here to the green boxes. So if I have 3/4 plus 3/8, one of these has to change. And remember, it's always easier to make this into the bigger number, right? So 4 times 2, we know that this is 3/8, and we want to make this into an eighth as well. So 4 times 2 equals 8. And remember that whatever we do to the bottom, we're going to do to the top. So an equivalent fraction for 3/4 is 6/8, right? Now when we add these together, we get 9/8. And that's too big. It's an improper fraction, isn't it? So another way to look at that is to say, oh, this is the same thing as 8/8, or 1 whole, plus 1/8. All right, that's what 9/8 is. It's 1 whole plus 1/8. So our answer is 1 and 1/8. Now we can also do that with the algorithm, right? We can say this is 9 divided by 8, because the line means divided by. So if we go like this, we do that. That's a pretty simple math problem. 8 goes one time, right? And 8 times 1 is 8. We subtract and we get 1. So we end up with 1 and 1/8. 1 and 1/8. Right? Okay. All right, let's do number 3. Here we go. I kind of like doing this. When I was a kid, I hated doing it, and now I kind of like converting improper fractions. It's kind of fun. So I have 1/3, because there's several different ways to do it. You could also do it with drawings, right? So I have this problem, and that's the same as this plus this. I'm just copying the green boxes out of the book. Right? That's what it looks like in the book. And you're going to start seeing the little green boxes on your worksheets. They're gray. So if I have this, I know that it's easier for me to make this third into a 12th. So I want both of these to be 12ths, right? And if I need to do that, I'm going to multiply the top and the bottom by 4 to do that. So 3 times 4 is 12. 1 times 4 is 4, right? And now I have 4 twelfths plus 5 twelfths, and that equals 9 twelfths. And so I don't really have an improper fraction. So I don't really have to worry about changing that. I just have 9 twelfths. I do have to simplify it though, because it's not in simplest form. So if I go ahead and put it in simplest form, what I'm going to want to do is divide it by the same number on the top and the same number on the bottom. Think for a second what you think that number would be. I think we could divide the top and bottom by 3. If we do that, that's going to give us 3/4, right? So our answer is going to be 3/4. So we didn't end up with a mixed number when we added those together. All right, let's look at number 4. Our last one is a doozy. A doozy, because we're adding 3 numbers together. So don't worry though, we're going to add 5/6 plus 1/12 plus 1/6. And that's going to be the same as green box plus, let's use our line here, green box plus green box. And then we have the same thing. We have equals green box, and we have another green box. And I know that when the green boxes are standing on their ends, when they're vertical like this, it means that there's going to be a fraction as the answer. It's kind of a cool little hint they give you. So we have a problem here. We have 6th and 6th, and we have 1/12. So I'm going to leave 1/12, and I'm going to multiply the tops and bottoms by 2. Right? Because I want to have 12ths all the way across. So 6 times 2 is 12, and 5 times 2 is 10. This is totally going to give us a mixed number. So 6 times 2 is 12, and 1 times 2 is 2. And now I have 10 plus 1 is 11, 12, 13. So I have 13 twelfths. Oops, lights just went off. I'm having to be much more aggressive with my arm waving to make the lights go on. Sorry. So now if I have 13 twelfths, that's the same thing as 12 twelfths plus 1/12, right? So that means my answer is going to be 1 and 1/12. Now another way to do that would be just to say 13 divided by 12. which looks like that. When I divide, 12 goes one time into 13, and 1 times 12 is 12. And when I subtract, I get 1 and 1/12, right? Same thing. 1, here's my 1. We could put a triangle around this guy. The remainder, and then the divisor, we could put a square. Right? So it's 1 and 1/12. It goes in a circle. This is your whole number, and this is your fraction right here. Numerator, denominator, right? Triangle, triangle, square, square. Circle, circle. All right. So I hope this helped you to add numbers together and realize that when you add numbers together, sometimes you're going to get an improper fraction when you add fractions together. In fact, a lot of times you might get an improper fraction. And then you have to convert it to a mixed number. All right? Because we really don't want to see improper fractions. We would prefer to see mixed numbers in your answers. Okay? All right. I hope this helped you to learn how to convert numbers. And thanks for joining me, and I will talk to you later.